Point interruptions, teachers, bus 22 and 24 just arrived. 124, please. Sorry, bus 22 and bus 24 have just arrived. Please allow those students into your class without authority. Reminder, students, you are not to wear any headgear that includes, but is not limited to, hats, scarves, beanies, things of that nature. Also, students, please make sure that your cell phones are put up. If your cell phone is seen out, then the teacher can take your phone. If you refuse to give your cell phone to the teacher, then you will receive some sort of discipline. The only reason that you should have your cell phone out in class is if the teacher has directed you. Again, the only reason that you should have your cell phone out in class is if the teacher has directed you. Another reminder for my young ladies, jeggings are jeans because they're jean leggings, and you cannot wear jeans here at Lexington Senior High School. You all have a very nice day.
Sounds a tad complicated.
Bus 202 just arrived. Please admit those students to class. Also, students, one reminder as well. Monday, your exams will begin with first period exams. Tuesday or second period exams. Wednesday or third period exams. And Thursday or fourth period exams. All teacher-made exams should be given by Thursday and Friday of this week. Students, your cell phone will be turned all the way off and turned in to every teacher at the beginning of the exam period. This is very important, as if a cell phone is found on you during the exam period, if it goes off or anything, your score will be canceled and you will fail the course. Thank you. Have a great day.
All right, so Ollie was tardy, Kato was tardy. I'm just assuming you weren't on wait list. It's not here. Fonte is not here. Online, got Alex, Fraser, Alex, Angel, Lisa here. And Chris, Major, Are we done? What are you happening? about now? Yes, no, need help, where are we at? Need help? No? Done? Help. All right. So you're just not done. You are done. Caroline's just staring at me like, please God, let it go. Sailor has their head down. I was just looking at you. So where are you at in the process?
Trying to figure out what you're doing.
What we're doing?
No, it's not. We trying to figure out what you're doing.
I'm trying to figure out where y'all are in the opening.
I think we
I
you
need-
helped us do it.
We just need to go over.
That's probably.
Yes.
Okay, all right. So if we look at number one, okay? So 1, 2, and 3, I'll go with the top equation. And I want to know
Oh, maybe not.
what happens to the concentration of NO if we do those 3 things. Okay? So let's just start with number 1. If I increase the concentration of oxygen, what happens to O2 to NO? Okay? So what's the first thing you have to figure out? What's the first thing I have to know? If I want to know what happens to NO,
Where the reaction goes.
yeah, I need to know the direction of shift. Okay? So if I add, all right, that's too wide. There we go. All right, so if I add O2, all right, what side of the equation is O2 on? That's on the left. So what was the rule yesterday for adding? Did it go to the same side or the opposite side? It goes to the opposite side. Okay? So what is the opposite side of where oxygen is? Where is oxygen at? Okay. All right, so oxygen is where? So which way does it shift? It shifts to the right. Okay, so it's going to shift to the right. Now, what side is NO on? It's on the right. So if it shifts to the right, NO will do what? Will it increase or will it decrease? It will increase. So number 1, NO will increase. Now, you got to do the same thing for 2 and 3. So, if I increase pressure, what's the rule for pressure? Fewer moles. Okay? So when you look at the moles, what can you tell me about the moles? Same moles. So what happens if they have the same moles? Stays the same. There's no change. Okay? So, if temperature is increased, what happens if temperature is increased? Goes to the cold side. How do you know which one's the cold side? The one that doesn't have the number on it. So which one doesn't have the number on it? Goes to the left. Okay? So you know what's going to the left. So what's going to happen to our NO if it goes to the left? We know that will increase and that will decrease. So what happens if it goes to the left? Okay? It will decrease because NO is on the right. Yes? No? Or am I just making faces at me? Are you with us or no? Yeah? Okay. So, in number 4, here's a different equation. All right, what direction will the reaction shift if pressure is increased? What's the rule if we increase pressure? Fewer moles. So which side has fewer moles? Right. Yes. Are we good with that? You might ask something simple like that. It might just ask direction, or it might have direction and something else. And you might be able to figure out the answer just based on direction. All right, so it goes to the right. What happens to N2 if pressure is decreased? If pressure is decreased, what's the rule? Big number of moles. So what's that as big moles? To the left. So it's going to go left. Okay, so if it goes to the left, it will increase, it will decrease. So what happens to nitrogen? It increases.
That's 5.
Yep, that's 5.
And what was 4, right?
4 was to the right. All right, and the last one. What happens to HI if pressure is increased?
It stays the same.
How you know?
It'll increase.
They have the same amount of moles.
How you know?
It wasn't balanced.
Got to balance the equation. Okay?
You had, well, you had one done.
It's the only one I didn't balance.
Yeah. You could. I would have missed that.
I know. That's why I didn't do that. You can't be guaranteed that the state will balance the equations for you. You've got to check. If there's no coefficients, assume it's not balanced. Check behind the state. If you see coefficients, assume they balanced it for you. But if there's no coefficients, double check. Okay? So now that I put in the coefficient, what can you tell me about the moles on both sides? They're equal. So now you know that the pressure is what? It's the same. So it's not going to affect anything. Questions? Okay? Questions?
Are you going to go over like
Yep.
these?
If you want me to, sure. Can I borrow somebody's paper? Because I don't have one in front of me. Thanks. All right. Going to. All right, I need to send Jada out because I know she didn't take it. Who else didn't take the quiz from last week besides Jada? All right, I'm sending that out. You can let Mr. Wardlow go since he's gone out. All right, which ones am I looking at? I pulled this up in case y'all need a graph.
1 and 11.
All right. All right, 11, and no, 11 is not a graph, it's just a chart. I'll pull the chart up. Focus there. All right, so when you look at 11, it's got a chart or a table. All right, base your answer on the following. The table shows the normal boiling point of 4 compounds, okay? So you have 4 compounds and you have 4 boiling points. And it says, which of the following has the strongest intermolecular forces? How did we say we would determine who has the strongest intermolecular forces? Anybody who got the right answer want to tell us how we know the answer to that? How you knew? I mean, I know what I would give you as the answer. Yeah.
The highest.
The highest what? That's the answer.
Oh.
All right. The highest boiling point has the strongest intermolecular forces. All right. It's harder to break those bonds or forces that are holding them together if you have a higher boiling point.
Okay.
Yes. Okay. The highest boiling point has the highest intermolecular forces. That's exactly what you're supposed to use.
That's what I was thinking, but I think I overlooked the negative.
Gotcha. But yes, that would have been the answer. For those of you who are like, that was the made up answer I used, that was actually the right answer. Okay? And which other one you said?
1.
1. All right. So when you look at this, I'm going to write on Alex's paper here. Let me get up.
No.
All right. You're looking at which one releases energy, right? So this is where we talked about, think about who has to make the particles go faster. If you have to go faster, you have to add the energy, right? So from a solid to a liquid, you have to say plus heat on this side to get it to change into a liquid, okay? So the heat would be on this side. To change from a solid to a gas, you'd have to say plus heat on this side to get it to change into a gas. To get a liquid to change into a gas, you want the liquid particles to go faster, okay? So you have to add heat to this side, because think about it. You have a liquid, all these particles are really close together. You want them to change into a gas where the particles are really far apart, so you need those particles to go faster. If you're a solid, and you're in a fixed position and you want them to change into a gas that's really far apart, you got to add heat. You need them to go faster. Anytime you want the particles to move farther apart and to go faster, you have to add heat to them. So all A, B, and C, you need to add heat to them. So the heat is on the reactant side because you need the particles to move faster, get further apart. But in D, you're starting as a gas and you want the particles to slow down. So anytime you want the particles to slow down, you need the heat to be given off. Okay? So that's why the heat is being added as a product, and that's why the answer is D. Okay? Anytime you want the particles to slow down, heat has to be released. Anybody else have a question about anything else on the quiz? Caroline doesn't have to be the only person to ask anything. Anybody? Okay. Thank you, sir. I appreciate it. All right. Can we talk homework? Let them back in before I forget them. Nah, he can leave it open. Mr. Wardlow's going to go in and out. That way he doesn't have to use his key constantly. All right, so I should do 1 through 5. All right, so number 1, I'm asking you what K means. If K is equal to 1, which type of reaction is favored? The forward reaction, the reverse reaction, or neither? Neither. Okay, you'll have approximately equal amounts of reactants and products, so neither forward or reverse will be favored. All right, if K is very small, the reverse. If K is very large, forward. All right, so in number 2, I'm asking you to predict whether the forward or reverse reaction would be favored if we make the following changes. If we add HI, do we go to the same side or the opposite side? You go to the opposite side. Anytime you add, you go to the opposite side. So if you go to the opposite side, that's going to go that direction, right? It's going to be the forward reaction. All right, so if you add H2, H2 is here. Which direction is it going to go? Reverse, because it's going to the opposite side. All right, that one's forward. All right, if I remove I2, I2 is here. It's going to go to the same or the opposite side. If I remove, it's going to go to the same side. So that's going to be which one? Forward. And if I remove HI, HI is here, so it's going to go to the reverse. All right, what will be the effect of each of the following changes on the new equilibrium concentration of water? So you have to know whether it's going right, left, and then figure out what happens to water. Okay, so if I add HCl, is it going to the same side or the opposite side? Going to the opposite side, so it's going to shift to the right. So what's going to happen to my water?
More water.
More water, so it's going to increase. All right, if I remove chlorine, does it go to the same side or the opposite side? It goes to the same side, so is that to the right or the left?
Right.
It's to the right, so what happens to water? It increases. If I remove O2, does it go to the same side or the opposite side? So it goes to the left. And if it goes to the left, what happens to water? Decreases. And if I add chlorine, does it go to the same side or the opposite side? Opposite. So the opposite side to chlorine would be the what? Would go to the left. So what happens to water? It decreases. All right, so predict whether each of the following pressure changes would favor the forward or the reverse. If I increase pressure, I go to the side of more moles or less moles? More moles or less moles? Less, so which side has less moles? If I decrease pressure, I go to what side? Normal, so it has to be the left. All right, predict whether the following temperature changes would favor the forward or the reverse. If I increase pressure, I go to what, or temperature rather. If I increase temperature, I go to what side? Which side is the cold side? The side without the number, which is the what side? The left. And if I decrease temperature, I go to what side? The right. Questions? Because that's all I asked you to do. Any questions? Yeah, hopefully that at least helps you get some right answers on those types of questions on the exam. All right, we're going to switch to molarity and dilution, and then we're going to solubility graphs. We should have done all this yesterday. We did. All right, we did one like that yesterday. We need to do one like this today. All right, I'll give you a moment to write that down. All right, this is the second type of molarity question that I told you that we would most likely have to work, or you'd be asked to work on the exam. All right, we did one yesterday where you had to calculate molarity. And this is the other one that I told you that if I asked you to find molarity, this would be it. Okay, where they asked you to find a mass. And again, you have all the skills you need to solve these kinds of questions. And if you just think through the problem, most of you don't even need me to work the question. You already know how to solve the problem.
Would we use this in formula?
Yep. All right, so what are we going to do? What's the formula we learned yesterday? All right, so big M equal moles over liters. All right, so what do we know from the question? Tell me something we know. All right, 1.5 is the big M. So that goes where big M is. All right, what else do we know?
500 milliliters.
All right, 500 milliliters is going to become the what?
0.5.
Yep. So take your 500 milliliters. Like I said yesterday, I would have memorized this long before now. 1,000, 0.5. Okay, so that's going to be your 0.5 down here. So we're solving for moles. How do I solve for moles? What do I do? Cross multiply. Is everybody with Chris? Yes, no? Okay, so we plugged in the big M. We plugged in the milliliters, but milliliters have to be changed to liters, right? So we're going to cross multiply. 0.5 times 1.5 should be 0.75 if I'm doing it right in my head. Somebody with a calculator, check me. Okay, so the question doesn't want moles, it wants what? Grams. So what am I going to do? What'd you say, Sailor? Convert it to grams. So what am I going to do to convert it to grams? Draw a chart. Yeah. So moles to grams. What goes beside moles? 1. And what do I do to find grams? Add them up. See, that's why I told you. You guys have all the skills to do this question. We just need to walk through how to use the formula. So Na has 1, 1, and 1, because it's the same compound I used yesterday. 23, 16, 1. You get 40 for a mass because everything had a 1. Okay, so what's my answer going to be when I put 40 right there times 0.75? 30? Questions? Any questions about how we did that? Or do we feel okay about it? Okay, now, from there, the second formula that you guys will see possibly on the exam is M1 V1 equals M2 V2. Now, this one should look very similar to other formulas we use. What's it look like? Yeah, it looks like the gas laws. All right, the only difference is M stands for molarity instead of pressure or temperature. Okay?
What exactly is molarity?
Molarity is a concentration. You know how you can buy like juice concentrate and you can add water to it? Molarity just talks about how concentrated something is. So in here, I buy concentrated acid, for example. Instead of buying various concentrations of acid, for example, HCl, I buy, I think it comes as 37 something, 37 molar or something like that. And I just buy it as a very, very strong concentrated acid. And so I dilute it to whatever we need. So I dilute it to 6 molar, I dilute it to 1 molar, I dilute it to 0.1 molar. And Miss Thornhill needs it diluted to something, we dilute it to whatever she needs for her AP Environmental or her AP Biology class. We don't buy them in separate little bottles of whatever concentrations we need. I just dilute them to whatever we need them made at.
How do you know
How do you know what?
when you get to the right one?
I use that formula that A we just used and B this formula. All
Seems
right?
like a lot.
Huh?
Seems like a lot.
It's not at all. So for example, let's say
Would we solve it the same way as the gas law?
that I buy 12 molar HCl. Okay? Let's say that's the way it comes. All right? I buy 12 molar HCl and I dilute the concentrated acid using this new formula. Okay? You don't have to write that. All right? That's just an example. All right? Now, the only catch to using this formula is the units have to match. The only catch. So, do the volume units match? No, you can do them both in liters. You can do them both in milliliters. It doesn't matter which one you do them in. You just have to make sure your volume units match. So, the volume units do not matter. They just have to match. Molarity, of course, has to be in molarity. I just told y'all didn't have to write that. Why are you writing it? Oh, the orange? You're just writing this, right? Okay. I'm going to say, y'all better not be writing that blue. I just told you not to write it.
Okay, but we see what happens was when you told us not to write it.
So now I got to wait on you.
Yes.
Tell me when I can go.
So it's basically just like the gas law.
Yes, exactly.
So we're solving it the same way as
Yes, exactly.
But how is it like a gas one? It's not a gas.
It doesn't matter. The problem and the concept works the same. You still have pairs or couples of numbers. You okay over there, Salem? What's wrong? You look at. What time did you go to bed last night?
I woke up and I'm about to sleep.
Oh, I'm sorry.
Anytime. Mom tried to make me stay home. I'm good.
All right, so this would be a typical question. I'll give you a minute to write it down. Okay? All right, we caught up?
I have a question.
Yeah.
This is, not really. So the HCL, the outlet learning, the four axis, are they going to put this?
There will be acids and bases on your exam, and that's one of the topics we will not get to.
How many questions?
Probably 2. Any best guess. I don't think you'll see more than 3, but best guess is 2. Remember, I never get to see the test, so I never get to know the answer to those things. All right, so when you look at this, it should look very similar to a gas law question, okay? Now, I will point out that there is an acid-base question called a titration, and I know that name seems a little odd to you, okay? But it's called a titration. You know this is a dilution question because what can you tell me about these acids? Are they the same or different? They're the same. In a titration question, they will be different, okay? One will be an acid and one will be a base. I will tell you a secret. This formula will work for a titration if the mole ratio is 1:1. Given we're not going to learn how to use a titration formula at this point in time, use the dilution formula, pray for the best, okay? Because if it's a 1:2 ratio, you got no way to fix it at this point in time. Use this formula and go forth and pray for the best, okay? Now, given these are the same, this formula works just like what we learned with the gas laws. Couples and pairs have to go in on the same side of the formula, right? So when you read this, see how it says you're making 350 milliliters and you want this concentration? That 350 milliliters has to stay with a 0.75 molar. As long as they stay on the same side of the formula, it does not matter which side of that formula they go on, okay? Does that make sense? Oh, that's supposed to say 2. So, pick a side. It doesn't matter which side. So I'm just going to stick them over here. So 0.75 and 350 equals my 12 molar, and then I need V2. Now, the only thing I need to keep in mind is just like the gas laws, because this was a milliliter, my volume is going to come out in what? Milliliter. If the question wanted my answer in liters, I would need to make the switch. But short of that, it works just like what we learned in the gas laws. Nothing is different. Okay? So, 0.75 times 350 divide 12. I get V2 equals 21.8, and the units have to match, so they're milliliters. Okay? Does that make sense? Anybody having a hard time with that? Okay? Can I turn? Okay. We're there now? All right. Just to illustrate stoichiometry with titrations, see how this and this don't match? This would be what I'm talking about with a titration if you see it. Okay? They don't match. Okay? That would be something that would be a titration if you see it. Okay? If it's a 1-to-1 ratio, this one happens to be a 1-to-1 ratio. You can still use M1, V1 equals M2, V2, and you can get the right answer. Okay? Now, if you don't have like this one, see how it's got a 2 on it right there? It's not going to come out as the right answer. You can guess B and move on. That's up to you. Or you can try to figure it out. All right. Questions about that? You want to practice? Okay. Then we're going to do solubility graphs. Solubility graphs are not hard. I think I've got any copies of it. Yes, I did. I did. All right, we're going to do the odd. Okay, we're only doing odds. That only gives us 5 questions because we're not going to spend much time on it. These should be easy, and we should be in good shape.
With the 1 through 10 side?
Yep, the 1 through 10 side. Only doing the odds. Yes. Yes, you can. Find the answer key, which will not be in this notebook. Here are the answers so you can check if I'm helping somebody. You change it to moles. If you're doing molarity, we doing molarity? Yeah, change it to grams. Change it to grams to moles.
Wait, but how would moles be molarity?
Remember, the formula for molarity, of course. This sort of thing. Yeah, because remember, molarity equals moles over liters was the formula for that. And then dilution was M1V1 equals M2V2. So you've got to choose which formula you need based on the question. So if you're doing molarity, you need the top formula. Yes, ma'am. 2 moles. Yep. You have some questions? What'd you say? Yep. Okay, I'll try. Yeah, the mass is the same. I'll try. Just like you just did. Let me look. Yep, that's what I got too.
Just lost this calculator.
Yeah, it probably is. Change these batteries. Yeah. Yep. So, I don't want to see video, like, we're recording.
So after I changed it. Okay.
Yeah. Now put it on top and then put your volume on the bottom. Yep.
I feel like I'm doing something wrong. It seems real easy.
Sometimes it really is that easy. Not everything is hard like with shot lead. Question? Pick something. All right, this one's an easy one. Molarity equal moles over liters. Right? So it wants to know what is the molarity. So we're solving for molarity, right? So you need to find moles and liters. So what are we going to do with grams if we need moles? So convert. You can do this without a bunch of numbers. Big M. It means big M.
Okay, so then, yay. Did I do this one?
Looks right. I don't see anything wrong with it. I can't see it. Yeah, then you got to find the mass of whatever goes there. So what's the mass of the compound?
Oh, that's.
Miss Wall, I have a question.
Yeah.
I wonder if I got 0.4 right here.
Hmm?
I got 0.4 right there.
How'd you get 0.4?
I used the whole numbers.
See how it says 0.5 molar solution? That 0.5
Oh,
is
wait.
what goes there.
I meant when I divided that.
Why did you divide it? You cross multiply this.
So it's yeah, I did.
Because this is here. You have like a 1 up there. See what it say 1 times 9.
Oh, you put the 1 down here.
Yeah.
Okay. So it is
Cross multiply there. Of course, again, you don't do really much right. Close enough, yeah. Yeah. Okay, so that goes on top for moles. And then divided by the volume. Voila. Good. Number 3. Again. Question? Yeah.
Oh, I used
I mean, you ran. I mean, I'm assuming if you ran a little bit today, you'd be able to tell what's the right answer on the exam, right? There you go. There you go.
I'm 3.
Yeah.
Oh. I don't know if that would be right. This is the gram. I was just like that.
Yes. Now, when you multiply here, I found moles, right? So it's 0.5 times 2. So then you have 1 mole, and for your chart, this is going to be moles down here, right? And grams up there. So whatever you found here, go on top. Question next. Formula is molarity equal moles over liters, right? So what are you going to do with that? You're going to change it to what? So change it to moles and plug it in on top. Then you have your volume. You can put it right there. You can do that. Okay? Then you can do it. You've been doing it for a long time. What the? is that? Hold on. You don't know something. All right. You're doing number 2. I wonder how that's going on. All right, so we took that, we changed it to that. Okay. All you did wrong. That's it. Flip that one chart. Now you're good to go. Although we are doing odd numbers, by the way.
Oh, yeah.
But it's okay. I will just skip number 3. Or skip number 4. I mean, 5. Skip something. So you get down to dilution. Okay. So you want to draw this. Put grams there. Okay. Then you put the moles on top. What number goes the moles? Yes. You remember how to find a gram from this compound? And you add that.
This one?
Yeah.
For SO4, is it supposed to be a smaller board and everything up?
Yeah, it's supposed to be small for it's just typo.
There's one.
This is a what? A big hand, a small road. What that include the big hand? Like that, and then include the volume, which you gotta change the word first. And then go across multiple times, molds, and you'll change both strings. Okay, so what's that A? Let's write that times 1. And then boring. That's really a mess. Okay. Nothing's going to turn out to be in scientific notation in these questions. Okay, put that one down. Okay, now calculate your moles. Okay, so, hold what's this? Okay, here, so 15 times 1. You good?
No.
What do you got?
I mean.
And ask what was the answer supposed to be? 4 times 16 is not 48. 64. Yes. Okay, so that holds it. All right, so that's our moles. Now, we have to put these moles on the top. Then we have to put our liters on the bottom and calculate the molarity. Does that make sense? Okay, so plug those in your formula and you got it. It's just the reverse. Which one? Did you change that to leaders? Who else? What's the question? Maybe else? You got done? I'll walk over there and say, sheet number one, you got work. So I walk over there, it's blank, I'm going to beat you up. Thanks.
It says 100 million
So what?
Is
Yes.
Who's wrong?
Yeah, yes.
Oh my
Oh my God, what's wrong?
God.
All right, so you did that, you cross multiplied, except it's not grams. That formula says moles right there, so that's moles. So put moles there. Now flip it. You got a question? No secrets. I won't even pretend to be insulted. Who has a question? Other than Lolly just getting help from someone else. Feel better now? Good. Okay. Won't be the first time today. You prepared to use a hall basket?
Do I have any left?
Don't know. You take a look. Nope. Got lunch tension. You don't serve, you just can't go again. At this late date in the semester, probably won't ask again. Take the hall pass. This full wall. After 30 cents for.
So question.
Yeah.
What exactly do you guys talking about?
You use all your hall passes?
Yeah.
It's just the way it is.
Like, is there a reason as to why you did that? What were your names?
Oh, because in some other classes, my children would go to the bathroom like a revolving door.
So we have to separate.
Yes, you have to suffer. Sorry.
Now that could pull out your heart just a little bit. Obviously. Isn't it? Where's the misunderstanding?
What?
You know, when I watch the local news, they, really have a very small chance of bad weather this weekend. When you look at the Weather Channel,
Huge chance.
well, they got a lot higher chance than the local weather.
What does it say?
Nothing positive,
I want to know what it says. Because I can't do
although I just closed it out. Go back. Let's see. Saturday, evening. Snow to wintry mix. Snow in the evening will become a mix of wintry precipitation overnight. Clouds, the chance of precipitation 90%, snow and ice accumulating 3 to 5 inches. Sunday, wintry mix to rain. A wintry mix in the morning will transition to mainly rain showers. That's good. That would wash it all away. Chance of precipitation 70%.
What does it get down to night? That's the question. Sunday night.
40. That would be good. Oh no, that's during the day. Sorry, that's during the day.
What's the low?
Sunday night, rain, snow, 30 degrees. Rain and snow in the evening, transitioning to snow showers late. Chance of snow 50%. Snow accumulations less than 1 inch. That's good.
So it only it could be 6 inches afterwards.
They say it's not supposed to accumulate much on the local news. Monday, AM snow showers, snow flurries, which is great. Flurries.
Monday during the mail?
Yeah.
I don't know.
I mean, the local news doesn't give it much of a chance.
Chance.
I need to just watch the local news.
I don't know.
Weather Channel's
I just
depressing.
think it was going to snow last time, and it freaking blizzard. I guess you think it won't.
I need to just watch the local news. Because if I watch them, I'm going to be depressed.
Are you really depressed? I don't know. I want to get this exam over with because I'm not going to keep forgetting it. And then, that won't be
Let's go there.
What time do you want?
Where? Because it says 100 of a 2. You need to keep the 100 of a 2 together. 100 and the 2 stay together. How much of a 12? The question mark and the 12 stay together.
Oh, wait. Cool. Oh, okay.
All right. Those of you who are still working on the math, that's fabulous. We need to move on. All right. We have 35 minutes to learn about solubility graph. Okay. Now, we're going to talk about the definitions, and we're going to talk about the parts of the graph. And then for homework, you're going to have to do the graphs. And then tomorrow we'll spend about half of the class on nuclear chemistry, electrolytes and acids and bases, and precipitation reactions have just been thrown out. I just can't get to them. 6 days would have made all of the difference in the world.
But are they going to be like big things?
I'm hoping for no more than 5 questions out of 40 that you will not know. I'm hoping for no more than. I can't fix it at this point. 6 days is a lot of days that we didn't make up. I was not prepared for not getting any of them back.
Well, I'm sorry.
Yeah, I am too.
All
Alright, now, so if we talk about solutions, there are 3 types of solutions that you might see on the exam. Alright, unsaturated solutions. Now, I don't care if you write the definition down. We can skip the definitions. They're not going to ask you a definition on anything. Alright, an unsaturated solution is a solution in which you have less than the maximum amount of solution. Okay, so how are you going to know if something is unsaturated? Unsaturated means, for example, you have a cup of coffee, cup of tea, cup of anything. Okay? If looks terrible. I can make that a little better. Okay? Let's say I dump in some sugar. What's going to happen when I put sugar in my hot coffee or hot tea?
Dissolve.
It's going to dissolve. Okay? Now, because the sugar dissolves, It is unsaturated. Okay? As long as the sugar dissolves, it is unsaturated. Okay? Less is in the solution than can be in the solution. Now, you know it's unsaturated because when you stir, do you feel any grit or anything on the bottom? No. Okay? That's how you know it's an unsaturated solution. Now, and you may not want to write all of this. The graph is more important than the definitions. I'm just trying to put it in context for you. I need to shut the dinging off. I just don't want to deal with it at the moment.
Please.
I'll figure it out during my planning
Where is
period.
it coming from?
My watch. I hadn't played with it. I took it off last night, and I always forget to do it in the morning. All right. So, what, I need to go back? Told you don't have to write all of it. I'm just trying to do this so you have some context for the graph.
Wait, so I don't know.
What?
If there's like 5 questions on the exam we don't know, there's 5 field test questions. Well, the field test questions like average ends, we'll have a greater number of questions. We don't miss
But it could be the field test questions or the questions you don't know. I have no way of knowing.
But like,
The field test questions do not count against you.
but what I'm saying is, would they like,
Would they help us?
would they help us have a greater number of questions so they count less? Or will it say that we have more points lost?
No. There will be 45 questions that you answer
And our scale will be based
on the 40. Yes. Yes. And you won't be able to tell which one's which. All right, so a saturated solution means you have the maximum amount dissolved in the solution. So, where do you see saturated solutions? All right, let's assume for a moment that you went to a restaurant and you asked for tea. Nastiest stuff on the planet, but let's just say you did. And they don't have any sweet tea. So they brought you some unsweet tea. I know. I don't like any of it, so it's all due. So, what's the first thing you do when they bring you this unsweet tea? Yep. Everybody put sugar in it. Now, because this unsweet tea is already cold, and you dump all the sugar in it, does the sugar dissolve very well? Nope, it doesn't. So, all of the sugar that can dissolve is already dissolved. So what you wind up with is a solution that's saturated, meaning no more sugar can dissolve. It is saturated. So, by dumping all that sugar in, all you can hope for is that when you're stirring or sucking it up through the straw, you get a mouthful of sugar along with that unsweet tea. Okay? Because you're not going to get all of that sugar that you dumped in to dissolve in that glass. Now, this, to link it to something else we've already done, is also at equilibrium. When you guys are stirring your sugar, believe it or not, the sugar is dissolving and recrystallizing. Now, can you tell which sugar is dissolving and which sugar is recrystallizing? No, but that's actually happening in the glass. Now, you can tell the sugar is saturated or the solution is saturated because when you look at your glass, what do you see all over the bottom of your glass? Sugar, okay? So you know it's a saturated solution. Have you ever made Kool-Aid and left a bunch of sugar sitting all over the bottom of your container? I would hope not. You made it correctly. But those people who use cold water have made a saturated solution of Kool-Aid, and there's sugar sitting all over the bottom of their container. Don't invite me over because I don't know how to make it. Okay? You'd be surprised at the number of people who tell me in a physical science class they make it with cold water. Okay? Does everybody have what they need? Now, the last one is a supersaturated solution. Now, because I know y'all are going to write all that. I'm going to shorten that. Because y'all will write too much. I'm just going to give y'all that. All right, this is when you have more than the maximum dissolved. Because we need to move on to the graph. All right, a solution in which there is more than the maximum amount dissolved. Now, they could ask you about the descriptions I just gave you, but truthfully, I don't think you'll see that either. I was only doing that to give you some context. I truthfully believe you'll see the graph, which is what we're going to spend the last 25 minutes on, and trying to make sure you understand how to read the parts of the graph. All of the released questions on this topic are on the graph. Now, if you have not started looking at the practice test that I gave you, please look at that before Thursday. There's no point in me going over the practice test questions if you've not looked at the practice test questions, okay? It's more meaningful to you if you've looked at them before we go over them, okay? Okay? I don't need the practice going over them. I've been practicing them since they released them in 2014, okay? I need you guys to do them. All right, so a solubility graph gives 3 pieces of information. Most graphs only give 2, but the solubility graph gives 3. It's going to give us the amount of solute, the amount of solvent, and the temperature. Now, the thing about the solubility graph is the amount of solvent is always going to be 100 grams of water. Okay? All solubility graphs always read is 100 grams of water. Now, the amount of solute can change and the temperature can change, but solvent is always read as 100 grams of water. Huh? It's just the way they're all designed. I don't know why they chose to do it that way. Now, you can alter the 100 grams, and I'll show you how to do that too. It'll probably be tomorrow, but we will get to that too. I don't think I have anything else on that board. I don't.
Right?
I didn't think I had anything else. I'm not turning it yet. So what? Yes. Is there anybody else absent besides Lolly yesterday? All right, do we all have it now? All right, so here's what the graph looks like. All right, it's going to be a line. The line can go up or down. I drew this one going up. Okay? The x-axis always has temperature on it. The y-axis has solute per, and again, 100 grams of water. Now, notice where I labeled certain things. Unsaturated is the area below the line. So anything below the graph line is unsaturated. Saturated is on the graph line. And that means supersaturated is where? It's above the graph line. All right? Anything that's unsaturated is below the line. Anything that's on the graph line is saturated. And anything that's above the line is supersaturated. I just wanted to see what I had there. Not important for today. All right. Typically, I would start with a single line graph. But that one has to be drawn, so you're going to do that on homework. I'm going to start with a multi-line graph. Odds are good on the exam, you will see a multi-line graph. Very rarely do they do single line graphs on the exam. This one is actually an old exam graph. All right, does everybody have what they need off the board? Because I'm going to make it go away. Go once, going twice, gone. All right. I need one side of the questions. All right, which salt is least soluble in water? First of all, what do I mean when I say salt? A salt is any ionic compound. Okay? Any ionic compound. So, the things on that chart that are an ionic compound is a salt. Now, what's an ionic compound again? Metal and non-metal. Now, it said least soluble at 20. So, what do you look for to be least soluble at 20? What do you look for?
The line that's furthest down it.
That's right. So, find 20 degrees. Find the bottom. Here's 20 degrees. Who's at the bottom at 20? KClO, and that's a 3. I know it's real blurry, but it's KClO3. All right? Everybody okay with how we do that? Yes or no?
Yeah.
Okay. Number 2. How many grams of potassium chloride can be dissolved in 200 grams of water at 80 degrees Celsius? All right. So there's a couple pieces of information there we need. First of all, which line are we going to read? Okay, we do need 50 degrees Celsius. That's important. It told me 50 degrees Celsius.
Miss Wall.
Oh, it was 80? Yes.
Can you send Owen Beasley to the office? He's due there.
Yes.
Thank you.
Welcome. Here, Owen, let me give you homework. You're doing this graph for homework. All right. So it's at what temperature? 80 degrees, okay? Now, I asked you which line as in which compound. All right, so say KClO3. Potassium chloride. Potassium chloride, what's IDE tell us? It's not KClO3. It's the KCl. IDE means it's got how many capital letters? 2 capitals. Means it's binary. Okay? This is one of the things we worked on in review last Thursday. Okay? KCl is binary. All right? You want KCl. KClO3 is potassium chlorate. All right? So we want that line. It told us 80 degrees. So you're going to read up from 80 to that line, and you're going to read over to find the solubility. What's the solubility? It's 50.
But you multiply that by 2.
Hold on. Per how much water? Per 100 grams. Now, the question asked you for how much water? Per 200 grams. So this is where Caroline's going with the do I multiply by 2? So the question did what with the amount of water? It doubled the amount of water. So yes, to answer Caroline's question, you have to double the amount of solute. So 50 times 2 would be 100 grams of solute. So that's how you get the answer. Does that make sense? Yes or no? You would have to write 100 grams over 200 grams. What? All right. So go back to the question. Tell me what compound it says in the question. All right. What is the line that potassium chloride goes with? The KCl, right? So that's why I highlighted KCl. Is everybody okay with me with why I did that? Okay. What temperature goes with the KCl? What? 80. Okay. Now, you have to read from 80 degrees Celsius up to the KCl line. So 80 up to KCl. Now, you read to the left to find the solubility. Okay. So I read from there to over here, and this tells me solubility. Is everybody okay with why I read to the left to find solubility? Okay, so what number does that line up with? 50. Is everybody okay with that part? Now, that's 50 per how much water? That's 50 grams per 100 grams of water. But the question doesn't want to know per 100 grams of water. It wants to know per how much water? It wants to know per 200 grams of water. So, in the question, they doubled the amount of water. So what do I have to do with the amount of solute? Multiply it by 2 and change that to 100 grams. Is everybody with us now?
So our answer would be the 100.
Yes, your answer would be this. That would be the answer. All right, I want you to try number 3 without my help. All right, we got it? Was that yes or no? Oh, no. Okay. I got a no and I don't know and a yes.
I did it.
Okay. I'll let Jada finish. You think you got it, Jada? Okay. So which line are we going to? What's this formula for potassium nitrate? All right, KNO3. So I have, this time I have, that's not lined up well. Try that again. All right, so KNO3 is this line. All right, what temperature are we using? What temperature did they say? 40. Okay. All right, so that's going to go past it a little bit. So I'm going to have to estimate.
43.
All right, I hear 43. If you didn't have 43, that's okay. Per 100. Anybody else? What did y'all pick? Because I know not everybody picked 43. 42. Okay. So if you had something different, you'll just adjust your answer based on that. All right, so the question this time said how much water? Per 300 grams. So what do we have to do to our answer? Multiply by 3. So this one's going to be 129 grams. This one's going to be 126 grams. Okay. Now, if you had 45, multiply and change your answer to accommodate. Okay. Questions? Anybody? All right. Number 4. Which salt shows the least change? All right. I hear NaCl. What do y'all think? What do you look for to see least change? The flat line. Okay, so who's the flattest up there? NaCl, I agree. All right. At 30 degrees Celsius, 90 grams of sodium nitrate is dissolved in 100 grams of water. Is it saturated, unsaturated, or supersaturated? All right, plot the point and see what you think.
Wait, I got mine on the line.
Is it supposed to?
Yeah, I guess. Wait, no.
I think it's under the line. I think 90's at the crosshair and the line is slightly above the crosshair.
I mean, I'm thinking the same thing, but like, is it so close to?
I'm going with no.
Okay, great.
Now, I would hope if they asked something like that on the exam, it would not be so close that we would have to make a judgment call. But I think it's below the line. All right, number 6. I said unsaturated. All right, number 6. A saturated solution of potassium chlorate is formed from 100 grams of water. If the saturated solution is cooled from 80 to 50 degrees Celsius, how many grams are precipitated? What do you think we do with that?
Subtract.
Correct. All right, so we've got 2 temperatures, so we need to find 2 what to subtract? 2 solubilities to subtract. All right, so what were we using? Potassium chlorate. So potassium chlorate is, where'd that line go? Right here. All right, so 50 will put us right there, and 80 will put us right there. So what 2 solubilities are we going to subtract? 40 and what?
20.
Yes, so 40 minus 20 is? Good. All right, what compound shows a decrease in the solubility?
Would you put that over on that?
Yeah, you would write 20 grams per 100 grams of water. All right. What compound shows a decrease in solubility? NH3.
Hold on.
What do you look for to see a decrease?
The line drop.
The line goes down. Yep.
Is this 7?
Yeah.
Can you repeat that?
Which compound shows a decrease in solubility? What are you looking for on the graph to see a decrease? The line to do what? Go down. So which line goes down? That's why they said ammonia. Because you remember that's the formula for ammonia.
I didn't know this.
Oh, okay. I got you. All right. So number 8. Which salt is most soluble at 10?
AI.
All right. I hear Ki. Does anybody else agree? Oh, 10 is below 20, and they just didn't put a number there.
Can we get into the second one?
Huh?
Can we get into the second one?
Yeah. All right. So 10 would be here. So it would be there. So do we agree with Ki or no?
Yes.
Yes, Ki is correct. All right. Who is least soluble at 50?
Potassium chloride.
All right. I hear potassium chlorate. Yay, nay?
Yeah.
Yes.
Is that
All right.
3 or a 4 next?
It's a 3. All right. And the last one, I warn you now, is a trick question. Which salt is least soluble at 90? Okay, why?
Because ammonia is not salt.
That is correct. Why is it not a salt?
It's too.
Very good. Okay. NH3 is covalent. And remember what I said. A salt has to be an ionic compound. NH3, even though it's the lowest, is a covalent compound, so you can't pick that one. Okay?
NaCl, you said?
Is it what?
NaCl.
Yes, because it's on. All right, for homework tonight, I got 2 papers to hand you. Only because I screwed up. Back in the day when I had plenty of paper, I used to do it this way, but I forgot to hit 2-sided. So it makes it easier for you because you don't have to keep flipping the paper back and forth. You got to draw the graph to answer the question. This is a single line graph. Here, Tom. Thank you. All right, you're just drawing a single line graph and you're answering solubility questions. It's very short. So tonight, after you finish this, you need to work on your practice test.
When you get over here, I have a question about what we do.
Yes, this is today. For 4:30. For you. If you're here, great. If you're not, I understand. Yes, but here, what's your question?
Okay, I'm not gonna see.
Okay, hang on, hand these, and I'll be right there.
Would it come like a little bit late?
Like how much, like?
Maybe like
But it's
30 minutes? Yeah.
chemistry.
20. Because I have like man.
Went from 40 up to this line. Just tell me, we'll see.
What are we going over?
And I gotta work on my skills because I'm showing up for car work.
I don't even know if I'm going.
I'm show off for car too.
I don't know if I'm going. Because of, yeah. We're battling. First of all, this is for my kids. Second of all, they already talked about. Already.
20. Yes.
I mean, and if we do that, then we might be able to.